Hi, I'm Arthur. Welcome to my lab. So I bought another tech oscilloscope. Not that I need another tech scope or analog scope, but it was cute and I wanted to play with it and I wanted to see how far I can get trying to fix it. It's a Tech 2215A and unfortunately it doesn't have trace, but if I turn it on and hit the beam finder button, it actually does show the beam. It hasn't warmed up yet. It does show the beam. It's just that it's offset. So I'm hoping that just replacing some caps in the power supply and of course replacing the refus in it, I can restore it to its previous glory. There we go. So there is a bit of a trace here. It actually used to look better when I first bought it. And let's see what happens. Let's see if I can get this thing working. After I took off the cover of the scope, this is the bottom of it. And nicely enough, there's a nice big cover with a nice warning covering the high voltage part, including the 2 kilovolt part. Although, strangely, they decided to put the 2 kV section, 2000 volt section, right around the place where you would grab the cover to lift it off the board. So that's kind of weird, but at least there's a warning about it there. And immediately I can see that there's some browning here. The board got cooked a little bit. Maybe that's something similar to the browning here, where there's a bunch of power resistors mounted on the board, and they basically heated the board to this point. I'm surprised that they didn't get mounted on longer legs so that they stand away from the board and don't heat it up as much. But maybe that's just the requirement of the circuit for them to be mounted close to the PCB. But the resistors on the other side look fine. Let's see if I can flip this crank. I'm using my parts boxes for standoffs because I don't want to put this on the floor. But here are the power resistors, and they look fine. So that part should be okay. I'm not concerned about that. But I need to get to the power supply to take a look at the caps and measure them and see which ones need to be replaced. Typically, the first thing that I do is discharge the CRT, the high voltage on the CRT, but this connection is kind of weird. That's not what I'm used to. Usually there's like a rubberized cap covering the connection. This seems like a different kind of glued over type of connection. I'm not sure if I can even lift it to discharge the cap. I'll have to take a look at the manual, and maybe I'll just leave it as is and wait, give it I don't know, a week or two for the charge to dissipate, and then I'll start digging into the circuit. But that's how this thing looks like from the inside, and more to come. So I found the voltages that I'm supposed to be getting out of the power supply that power the rest of the circuit, and you can see the 8.6 volt, the 5 volt test point, the plus 8.6, and somewhere here is plus 100 and plus 330. So I measured those, and the good news is that they are correct. The bad news is that they are correct, and so it appears that the power supply is fine. Other than replacing refus, I probably won't have to do anything with the power supply, but that means that the problem lies somewhere else in the circuit, and that some more complicated troubleshooting will be needed. So I'll have to dig deeper into the schematics and try to figure out what's going on. I'm hoping that it's not the high voltage power supply that's causing this, which I'm guessing it's not, because I do get image on the tube. It's just that I don't have the deflection. So maybe that's the circuit that generates the deflection, or maybe it's the part of the high voltage circuit that does the deflection. We'll see. So a bit of an update. It was a pain to get to these refas. They sit on this little daughter board here, filter board, that is mounted to the back of the scope under this little shield, and it was just a pain to get that board out because it's connected to the fuse and the input socket for AC with relatively short wires. I didn't want to mess with those wires, so I just kind of bent this board here out of the way enough so that I could reach the refas, which of course are on the very bottom of this board, not at the top where it's easy to reach. But now this little blue refat right here, that's the new one. So these are replaced, and since we know that the voltages coming out of power supply are correct, I can just close the PSU and cover it and hopefully not mess with high voltages from now on. One other thing that I forgot to mention is that as I was moving around this scope trying to figure out how to unscrew things, I could hear some rattling, and initially I thought it was this plastic actuator for the power switch, but no, this is solid. Turns out that there's a ferrite bead right here next to this cap. You can barely see it here, and this bead is just, see, floating around loosely. It just has one wire going through it, and the wire is soldered to the PCB, but the ferrite bead itself is free to flop around. So I'm kind of surprised that Tech did this, because usually, you know, they're excellent at securing things in place, but this guy was just left to flap in the breeze. Since we're having trouble with deflection, one of the first things that I'm going to do is measure the supply voltage on the custom chip that is the horizontal deflection amplifier, and I'm hoping that this chip, yeah, -5 is good, and hopefully I'll get +5 as well. Yep, 5.248. I hope I didn't just smoke this chip because I quickly shorted it. Nope, still measures okay. So that was the horizontal deflection amplifier, which is a custom chip. So at least it has the power supply to it, but I don't know whether that's good or bad, because that would mean that, you know, if it didn't get its power supply, I could simply replace those parts. This chip, if it's smoked, then I'm in trouble. But let's continue troubleshooting. Next, I need to measure test points 32 and 33 in the manual, which I'm expecting to be between 25 and 70 volts. So let's take a look at those guys. 32 is right here. And I'm not triggering on that. Let's see. Trigger on channel 1. Yeah, I'm triggering at nope, not getting a trigger. I'm triggering at 40 volts. I got 70 volts here. Nope. I got high voltage here, low voltage here, and no deflection signal. I'm not sure what changed. I was messing around with the controls. I pushed the beam finder, and I was able to see the scan, the horizontal sweep. And so then now I started measuring. I adjusted my scope settings, and I am getting a sweep. So here's one sweep, nice and solid. Here's the counterpart, down sweep. So both of them look okay, except they only sweep down to 30 volts. They're supposed to range between 25 and 70 volts, and I'm only getting 30 volts. So I wonder if that's a problem. But when I pushed the beam finder, I was only getting sweep across the like maybe quarter of the display in the center, maybe a third of the display in the center. So I don't know whether that's how the beam finder works or what. I'm not sure whether this 30 volt sweep is sufficient or whether I need to get it to sweep to 25 volts. I'll have to dig into the manual, but I'm happy to see the sweep. That's good news. So here's the result of my sweep. I just did a single sweep and enabled cursors, and as we can see, the sweep goes from 30 volt to 70, and the range is 38 volt. So yeah, 28.8 to 67.2, depending on accuracy of these cursors. So I'll have to figure out whether that's sufficient or whether that's a problem or part of the problem. Actually, I think I may be in business. See this nice waveform? When I was recording one of the previous bits, I mentioned that I didn't remember what I did to get that sweep on the beam finder, and then I thought that I was messing with these switches here, and these switches are kind of glitchy. They don't make a good contact. So sometimes, I push it, and of course now it's not doing it, but I'll push it and see, it won't latch on, and now it latched. So I think that maybe these switches need a little bit of deoxide bath, and maybe that will do the trick, because right now I'm getting nice sweep. Never mind that the probe is not compensated. This is a probe for my Owen scope, so it's not adjusted to work with this scope, but I'm getting a waveform, and I'm getting it on both channels. So if I switch to second channel, I'm getting a nice waveform as well. Both channels work, and yeah, I'll test this scope a little bit more, but I think I may be in business. The only thing that I noticed was also when I depressed this bandwidth limit, I was getting some glitchiness on the first channel, but let's see. No, now it's good. In alternate mode, yeah, it's good. Add, it's all solid. So maybe all this scope needs now is have its switches take a little bath and deoxide, and that might be it. So yeah, this turned out to be not much of a repair video, because once I flooded the switches and contacts as much as I could with deoxide, the thing just started working. And it feels like most of the deoxide really sprayed on the faceplate and all around, because I couldn't find a way to get really into the switches. But at least, that got it working. And now I have another scope in my nice collection of analog scopes. So it joined its big brothers, the 2465A and the 2245A, and it's doing great. Now I got it connected to my Thai kit of the curve tracer that I got from eBay from Thailand, and yeah, it's the curve tracer plus another thing for comparing transistors, and a spider circuit that I put in one enclosure, along with output voltages of plus and minus 15 for that I can use for testing, and yeah, it's working nice.